Transmission impairment. The signal travels through transmission media, which are not perfect. The imperfection cause signal impairment. That means that the signal at the beginning of the medium is not the same as the signal at the end of the medium. What is sent is not what is received. Three causes of impairment are attenuation, distortion, and noise. Attenuation means a loss of energy to compensate for lost amplifier. How the signal has lost or gained strength, we use the unit of the decibel. Measure the relative strength of two signal or one signal at the two different points. So we can calculate with this. This is a problem and how we can calculate it. Support the signal through the transmission media at a power reduced one half. It means P2 is one half to P1. Indicates attenuation or loss of power can be calculated like this. This is the example for the signal and its power increased 10 times. Means P2 is 10 times P1 and we can calculate it like this. This is the example and we all can calculate it. So another one is distortion, means that the signal change its form or shape of signal. You see in the pictures at the centers, this is the composite signal and components in phase. And at the receiver, each change composite signal receive. And another one, noise. Several types of noise, such as the thermal noise, induced noise, crosstalk, and impulse noise, may corrupt the signal. Thermal noise is a thermal. Crosstalk is mean that crowds talk to each other and it is noise to the communication. Two cases of SNR, a high SNR and low SNR. SNR means average signal power or average noise power. You can calculate it in this. So the picture, you see the picture when the last SNR, the signal go through and with noise. So the receiver can get the signal like the blue signal. And the small signal through the noise, you can see the picture. This is an example how to be calculated SNR and SNR in dB. This is the value of SNR and SNR dB for a noiseless channel. Oh, sorry. Data rate limit. A really important consideration in data acquisition is how fast we can send data in bits per second or over the channel. Data rate depends on the three factors: a bandwidth available, a level of the signal we use, the quality of the channels. Noiseless channel, Nyquist bitrate. Bitrate equal 2 plus bandwidth plus logs. L base 2. Nyquist theorem, the maximum bandwidth of noiseless channel. It means increase the level of the signal means reduce the reliability of the system. Noisy channel or channel's capacity. The channel capacity, the theoretical high data rate of noisy channel. So we cannot achieve the data rate higher than the capacity channel. This is the example from Nyquist theorem. So we can do like this. The example for calculated bit rate. This is how we use Nyquist formula. This is an example can calculate theoretical high bit rate. So this is capacity is calculated like this. You can see it. So this is all the calculated, and the Shannon capacity gives us the upper limits. The Nyquist formula tells us how many signal level we need. So 3.6 performance. One important issue in the networking is the imperformance of the network. How good is this? We discuss quality of the services and our over measurement of network performance in greater detail in chapter 24. In this section, we introduce terms that we need for the future chapter. Bandwidth in the network, we use the term of bandwidth in two contexts. First, bandwidth in hertz refers to range of frequency, the composite signal, or range of frequency the channel can pass. Second, bandwidth is a bit per second, refer to speed of bit transmission in the channel or link. This is example how we calculated the bandwidth. Throughput, the measure of how fast we can actually send data to a network. Bandwidth is potential measurement of a link, and the throughput is actual measurement of how fast we can send data. Imagine a highway like 1,000 cars and 100 cars. This is an example how we calculated throughput. Latency or delay. How long it takes for a time message for completing a write or destination from the time first bit can comes out by our file component. So this is how we can calculate the propagation time. This is we can calculate the propagation time and transmission time in for the example what we can calculate it. A bandwidth delay product defines the number of bits that can diffuse link. So you can see this the sender after 1 sec, 2 sec, 3 sec, and 4 sec, 5 sec. That bandwidth in 1 bps with delay 5 seconds. Bandwidth X delay is mean 5 bits. The bandwidth fueling link with bit is K2. Bandwidth with 4 bps with delay 5 seconds. Bandwidth and delay is mean equal 20 bits. At the 1 second,